Hey guys, in this video we're going to use what we learned in the past video to decide whether or not each one of these equations is a quadratic equation. I would encourage you to stop the video right now and go through and try and do each one on your own, and then once you've done that, turn the video back on and go through and watch along with me. So remember, the basic idea here is that we're going to try and rewrite each equation in standard form. If we can write it in standard form, then we're going to say it's a quadratic equation. So in the first one here, we have 5x squared minus 6x plus 2 equals 0. If I look at standard form, this first one matches exactly. So I have my squared term, or my a term here, ax squared, plus my b term, and then my c term, which equals 0. So ax squared is 5x squared, bx is negative 6x, and c, or my constant, is 2. So this one's definitely a quadratic. It was already in standard form. We didn't have to do anything. Okay. In the next one, if I go through and look at my terms, I have a constant, I have a linear term. Unfortunately, though, I have a degree 6 term, so this is not a quadratic. And it's because of the degree 6 term that I have there. In number 3, we have a longer equation here. All right, the first thing I'm going to do is I'm going to combine any like terms that I have. And remember, I'm trying to rewrite this in standard form. So if I look at it, I have negative 3x and 2x. Those are like terms. I can combine those. Negative 3x plus 2x gives me negative x. Right. Now if I look at it, I have a squared term, a linear term, and a constant. I'm pretty sure it's going to be a quadratic. But for practice, I'm going to rewrite it into standard form. And putting it into standard form is going to be useful because when I go to solve these equations, it's going to be easiest to solve them when they are in standard form. And I'm going to move everything to the side that has the highest degree term, so I'm going to move everything over to this side. So I'm going to add x to both sides, and I'm going to add 5 to both sides. So I end up with 0 equals, I can't actually combine 8x squared and x because they're not like terms. I get 8x squared plus x and then plus 5. So if I'm looking at it now, my a term is 8x squared, my b term is bx, and my c term is 5. So that one is a quadratic. And then on the last one, on number 4, I got a bunch of stuff I need to combine. So I'm going to try and move everything to this side because I have my degree 2 term over here. So I'm going to start by subtracting 5x from both sides. And I'm writing the 5x, the negative 5x, under the 2x because those are like terms. And then at the same time, I'm also going to move this constant. So I'm going to add 15 and add 15. All right, so 3 plus 15 gives me 18, minus 3x squared, 2x minus 5x gives me negative 3x, and on the right side, I'm just left with 0. Now this doesn't match standard form exactly. I don't have it written in the correct order, but I have a constant, a squared term, and a linear term, so I know it's going to be a quadratic. I'm just going to rewrite it in standard form for practice. So I end up with negative 3x squared. That's my degree 2 term, or my squared term, so I'm writing that first. Then I'm going to write my linear term, negative 3x, and then my constant plus 18 equals 0. And I'm all set. So that's a quadratic. All right?